This is sort of an add-on to yesterday's work on solutions. This is now new work. You did not do this in grade 10 last year, so make sure you're focusing, please. So we're going to look at dilution. I'm sure most of us have heard the word dilution in everyday English. This is one of the very few words that are actually used correctly in the English language when it's compared to the physics definition. So dilution is the process of decreasing the concentration of a solution by increasing the solvent volume. So it sounds a little bit fancy, but basically if you think about this is the one I always go to, when you dilute Oros, okay, so you put your concentrated Oros in a glass and you add water to it. So you're decreasing the concentration of your Oros by increasing the volume of your solvent, which is water in this case. So just to see that mathematically, we know that the formula for concentration of a solution, one of our formulae is C equals N over V. So we can see from this that the relationship between concentration of your solution and the volume of your solvent is an inverse relationship. So it's proportional to 1 over the volume, which means as we increase the volume, we're going to see a decrease in concentration. Okay. Now the formula for dilution, there's 2 of them. These are not on your formula sheets. Okay, got it. So far all the ones we've seen for stoichiometry will be on your formula sheet. This one is not on your formula sheet. And our formulae are C1V1 equals C2V2. So this basically means the product of the initial concentration and volume is equal to the product of the final concentration and volume. Okay, so let's quickly actually just draw a diagram of that. So if we've got a solution with a specific concentration where our solvent has a specific volume and we add solvent to it, so this is C1V1, we add solvent to it, then our volume will increase and our concentration at the end will be slightly lower. Okay, does that sort of make sense? So whatever your initial concentration and volume were before dilution, it will be equal to the product of your concentration and volume after dilution. So let's write here before dilution, and this is after dilution. Okay, then the second formula that we're going to use is that the volume, how did I word it here? The volume, so the final volume, V2, is equal to the initial volume plus the volume of water or solvent added. Okay, which also makes sense, right? If I have a certain volume of water or a volume of solvent that's involved in my solution, and I add water to it, okay, I'm going to end up with a greater volume, V2. So V1 plus the water I've added to it will give me V2. That's just sort of a logical step. It's not really a formula, it's more just a logical step. Okay, so these are our formulae for this section. Okay, now I'm going to do a few examples with you, maybe just 1 or 2. It's not that tricky. If you understand solutions, if you can do the calculations for solutions, you'll be fine for dilution. Okay, so I'm going to just pause here quick, write down a few examples, and then we'll get going. Okay guys, so here's our first example. We're going to determine the initial concentration of a 4 dm cubed solution that was diluted to 6 dm cubed with a concentration of 3 moles per dm cubed. So first off, we see the word diluted, which is a massive hint that this is a dilution question. They won't always say the word diluted though. So the next question I'll give you, I'll leave that out, and you've still got to try and figure out the fact that it is a dilution question. So first off, as usual, I'm going to list what I know. So with dilution, we're interested in C1V1, C2V2, and possibly volume of water added. Okay, let's see what we know and what we're after. So determine the initial concentration at C1. So we already know what we're looking for. Initial volume was 4 decimeters cubed. It is in the correct unit, so we can leave it. It was diluted to 6 decimeters cubed, so my final volume is 6 decimeters cubed with a final concentration of 3 moles per dm cubed. Okay, and they don't talk anywhere about the amount of water added, so we don't care about that. Okay, so let's go for it. We can go straight into this formula. Oh, sorry, just a heads up. These formula that I've written at the top are the formula you might need to use for the section. The ones I've written in black, those are on your formula sheets. These two in blue are not on your formula sheets. Okay, so we can jump straight into the dilution formula. C1V1 equals C2V2 and substitute in. We don't know C1. Initial volume is 4, final concentration is 3, and final volume is 6. Okay, so now we can solve for initial concentration. That's going to be our 3 times 6 over 4, which is 18 over 4, eh? Which is 4,5. So our initial concentration was 4,5 moles per dm cubed. Okay, always go ahead and check that your initial concentration, let me write that little as a note here. Okay, I'll check your initial concentration should always be, greater than your final concentration, because remember dilution is to decrease the concentration by increasing the volume. So your initial volume should always be less than your final volume. So just a little check. So let's check. My initial concentration, is it greater? Yes, it is. Okay, 3 compared to 4.5, the initial is greater than the final. Okay, I'm going to quickly write down a second example. Sorry, gotta pause you. Okay guys, here's example 2. So I want to know what volume of water should be added to a 12 dm cubed, two 12 dm cubes of a 3 mole per dm cubed solution in order to prepare a 2,2 mole per dm cubed solution. So here I've not used the word dilution anywhere, but we are adding water. Okay, we are adding water to a solution. That means it's dilution. Okay, as soon as you are adding solvent to a solution, it's a dilution question. Okay, so let's go ahead and write down our variables. So I like to list all of them: C1, V1, C2, V2, and V water added. Okay, let's go for it. So, what volume of water should be added to 12 decimeters cubed? So it hasn't told us what this is, but we need to determine that from the units. So the units here are units of volume. And we're asking, how much should I add to this? That means this was the initial volume. Okay, so initial volume is 12 dm cubed. Okay, of a 3 moles per dm cubed solution. Again, haven't told us what that is, but we can ascertain that from the units. The units are moles per dm cubed, which is concentration. So the initial concentration is 3 moles per dm cubed. In order to prepare a 2,2 moles per dm cubed solution. So at the end of all of this, I want that concentration. So my final concentration is 2,2. And I don't know the final volume, and I don't know the volume of water added. That's actually what we're asking for. Okay, so we are going to have to write, we know this is dilution, so we write the dilution equation. C1V1 equals C2V2. We know C1 is 3. We know V1 is 12. We know C2 is 2,2. We don't know V2, but we do know that V2 equals V1 plus water added. So we can expand that, okay, to be V1, which was 12, plus the volume of water added. Okay, so I hope you see what I've done there. I've taken V2, which I didn't know, and said that is equal to V1 plus V water added. And I've substituted this whole expression in the place of V2. Okay. And now we can go ahead and solve for the volume of water added. So we're going to have 3 times 12, 36, is it? Gotta just double check. 36. Okay, so we've got 36 equals, now we're doing distributive law here, so it's 2,2 times 12. There are many different ways of solving this formula. You could have also just immediately divided by 2,2, but I'm just going to do it this way. So we've got 26,4 for the first distribution, and then second distribution, plus 2,2 volume of water added. And we're solving for volume of water added. So we're going to hop that over, subtract it, and then divide both sides by 2,2. So 36 minus 26,4 and then divided by 2,2. And I get that the volume of water that I add is 4,36 decimeters cubed. There we go. Okay, now I'm actually going to leave it there for the examples. I've done two quite tricky ones. There are more straightforward ones though. So I just want to highlight the fact that if we had a similar example here where they wanted to know how much water was added, but they'd given us both V2 and V1, then we could just go ahead and say, well, V2 is V1 plus water added, so we could just go V2 minus V1. That would give us the volume of water added. We wouldn't have to do all of this. But in this case, we couldn't do that because we didn't know the final volume, V2. Okay, so I'm gonna send this to you. You have a worksheet called Dilution. I'll send it to the WhatsApp group. It is also on OneDrive. Please do shout if you need me. Guys have been very quiet, so I hope it just means that you fully understand all of this. You remember it from last year, but now this dilution is new. So please do let me know if you get stuck.